and then for each directions, you will have to go through the number of trials. So I typically don't encourage having too many for loops, but in this case, it is a bit necessary because we will have a different number of trials for each direction. And then for each trial, we're going to have the neuron probably fire for different many times. So whenever a variable always has to change its size, it is acceptable to do for loops. And especially drawing these raster plots are a bit tricky. So this is the one case where I do recommend just writing nested for loops. But yeah, there's no need for more than 2. Okay, this is the hint I gave you. So here you must find the spike times 1 second before and after for each trial given in direction I. Okay, so what does that mean? Okay, so let's say we are in trial 2 and the direction is 5 and go trial is 27. Okay, so if I say spike times is neuron 1, and then I say a find when neuron 1 is less than or more than go trial -1, and so that's 1 second before the go cue, and it has to be those times when it is in fact less than go trial +1. And I have to copy that. Let's say less. Okay, so oh, of course, I just needed to make these 0 and 1. Okay, so let's actually take a look at what the spike times are. So let me do that. Okay, so again, what was our go time? Our go time was almost perfectly 27 seconds. So we're interested in finding when neuron 1 fired between 26 seconds and 28 seconds. Okay, and in fact, this did give us all those times. Okay, but for us to do a raster plot, we want to basically align all of our trials to their relevant go cue. We really don't care when the go cue was. So let me go to here, right? So if this was our direction, we were in direction 5, and that's our first trial. We again don't care that it started at 27. We want to bring the onset of the cue to time 0. So to do that, what you can do is then say minus go trial. Okay, so once you do that, what we have now are values that are between -1 and 1. And these are exactly the same, those times where we want to be able to plot that raster plot for direction 5 for the first trial. Okay, now that we have these times, how do we actually draw these bars? All right, let's come to this, and for that, let's go back to my project description. In here, I actually give it to you, so, but in this case, spike times need to be row vectors. Let me check what kind of vector I have. In this case, I have a column vector, so I will have to transpose my spike times. I can either do it here or just then say spike times equals spike times transpose, but let's just keep it clean and do it this way. Okay, so now our spike times is a row vector. Okay, so then if I actually copy this, this will work. Okay, what's happening here is, and this was something I described in class. So for instance, our first value for spike times is, say, minus 0.95. Okay, so what this will do is create a column that's minus 9.5 and another minus 9.5. And that's for this first variable. Okay, that will be our x-axis. Okay, and this is our y-axis. And here, the variable j was the number of trials. So in this case, I am going to say j is trial. Or let me say j is 1, because j is the first trial for our direction 5. Okay, and n needs to be basically the same length as spike times. Okay. Let's see where the parentheses are missing. J is 1, n is length, spike times, plot. Oh, yes, there's one too many. Okay. All right, so what this did, and let me make these lines really thick. Sorry, I have a second monitor here, so things keep hiding. All right, so let me make that line really thick. And let me also change my y-axis so it's pretty clear. Let's do it between -1 and 2. Okay. Oh, it's just